Good morning, everybody. So what I would like you to do is take out your notes packet for Unit 2. You should have just grabbed that. And I want you to look at the first page. If you look at the first page, it says converting degrees and radians. You did this last year when you took Algebra 2, or if you took Foundations, you also did this. And there's a real easy rule right here, and there's a real easy rule right here. And I am going to go over that rule. But because we're entering into pre-calc, you're not going to have a calculator. So to do this rule is totally fine, and you'll see what I'm talking about in a few minutes once we get moving. But there's sort of like some little shortcut tricks to doing it so that the computations that you're doing in your head without the calculator will be easier for you. So what I want you to do actually is take a minute, or a second actually, and just turn to page 4 in your notes packet. So looking at the top of page 4, this should be familiar to you as well. We did do this in Algebra 2. Now I'm only going to talk about the angles themselves for a moment. We will get to page 4 in a minute, but let's look at what we call special angles, and those special angles will be 30, 45, and 60. We're going to deal with those angles constantly in this course. The other angles that we will deal with have to do with this unit circle over here. Remember that this starts at 0 degrees. When we rotate counterclockwise, this would be 90 degrees. Rotate another 90 degrees counterclockwise. This is 180, 270, and 360. And those are the angles that honestly we are going to be dealing with the most. So what I'm going to do is you can just watch for a minute. You don't need to take notes on this, but you're going to need to know it, obviously. Okay, so let's just take a look at 30 degrees. Okay, so if I wanted to take 30 degrees and I want to convert it to radians, you can go back, take a quick second, look back at the top of the page on page 1 rather, and it says converting from degrees to radians. You multiply by pi over 180. So I can take that 30 and I can multiply it by pi over 180. And what I'm going to do is just put that 30 over 1. Okay, so we don't have a calculator, no cheating. So we're going to multiply the 30 times the pi, which I'm just going to leave it as 30 pi, and then 1 times 180, which is 180. Now, here's where it can get a little bit tricky depending on how your mental math is. I have to reduce 30 and 180 in my head because I'm not allowed to use a calculator. Well, I have a little trick that if you have the same number of zeros in the numerator and the denominator, you can cancel them out. So really now all I'm doing is reducing or simplifying 3 over 18. And I know 3 goes into 3 once, and 3 goes into 18 6 times. Now I could put the 1 here. It's really not necessary though. And there's what 30 is. So 30 is equivalent to pi over 6. Now, if you could, maybe on page 4, I would write that above your chart. Okay, that's helpful. The work that I'm doing below, you don't need to really write it. All right, so let's try 60 degrees, okay? So 60 degrees, I'm going to do the same thing. 60, I'm going to put it over 1, multiply by pi over 180. And that's going to give me 60 pi over 180. I'm going to reduce, cross out those zeros, and I know 6 goes into itself once, and 6 goes into 18 3 times. So that's pi over 3. Okay, again on page 4, I would write pi over 3 into your notes right above the chart there. Oops, I put it in the wrong spot, didn't I? Huh. It should be over here. Pi over 3. Okay, all right, I will remove that pi over 3 over the 45 in just a minute. So now I'm going to do 45. Okay, and that's going to be 45. Throw that thing over 1, and I'm going to multiply by pi over 180. You see this gets a little tedious, right? This is kind of annoying. So 45 pi over 180. And this is where maybe some of you guys are good with math and, you know, mental math, and some of you not so much. I don't know how many 40. Well, let's see, 45 and 45 is 90, so that's 2 times. And if I do another 45, that's 135, and I do another 45, there we go. Okay, so that's going to go in, 45 goes into 180 4 times. That's annoying. So this I'm going to make a 4, okay? So that's pi over 4. All right. Now, we can do the same thing for all of these special angles, what we call our quadrantal angles, because they're on the border of quadrants. So we call them quadrantal angles. You should know that. Okay, but I'm just going to cut to the chase here. Okay, I'm going to write them. Obviously, 0 is 0 degrees. If we were writing it in radians, you can either write 0 or you can write 0 pi. Radians is always written with a pi. Okay, all right, so 90 degrees. Now, again, if I just bear with me, I'm going to get messy here for a second, but instead of 45, let's say this was 90. This would be 90, and 90 over 180 would be pi over 2, right? Okay, so I know that this is going to be pi over 2. Then 180, well, think about it, okay? Instead of putting a 90 here, I'd be putting a 180 here. So I'd have 180 over 180. So isn't that just pi? Okay, so 180 is just going to be pi. Okay, and I'm going to throw this over here. Take my word for it. 270 is going to be 3 pi over 2. And 360 is going to be 2 pi. Now, I would take these, okay, and I would put them down on page 4. So please have those, maybe in the top right-hand corner, right up here. Put those in your notes packet, okay? If you have to pause me for a second, please pause me and take care of that, okay? Okay, so now let's go back. We're looking at page 1, right? There's the directions up at the top, or the method of converting, okay? And we can certainly use this method. However, it does get time consuming, and it gets a little tricky when you're dealing with numbers that you're not familiar with and you are not allowed to use a calculator. So what I did over here on the right, and you can put this at the top of your page, so if you want to do so, then just pause me a minute and write these little facts at the top of the page. Now we did this, remember this is on the top of page 4 in your notes, and if it's not, it should be there. Okay, so these are really handy dandy, and I'm going to show you a shortcut to completing the conversions that are on page 1. So I'm going to just go down the first column. All right, so obviously number 1 is 45 degrees. So I just look over here and I'm like, oh, well, that's easy. All right, so let me just show you a real quick trick though for the 30, the 60, and the 45. The 3 here, look at the denominator, is 6. 60's denominator is 3. So a 3 goes with a 6, a 3 goes with a 6. So in other words, 30 will not be pi over 3. You won't have a 3 here and a 3 here. So it's a 3 with a 6 and a 3 with a 6. Thus, 45 is kind of easy. There's a 4 in it, 4 in it. Okay, so that being the case, then 45, remember, always has a 4 in it. And I know we can just cheat and look to the right of the screen there, but we know that that's pi over 4. Okay, now 160, I'm going to just leave number 4 for a second. Let's go to number 7, 210. So this is what you're going to try to do, is you're going to look at 210 and you're going to say, that's kind of a big number, and to multiply by pi over 180 and to reduce it, you can do it, it's fine, but you're going to get in the habit of doing what I'm going to show you. So 210, I say to myself, well, does 30, 60, or 45, can I multiply any of those 3 numbers by something and get to 10? So yeah, I could take 30. Think about 3. If I multiply 3 by 7, don't I get 21? So do you see that 30 multiplied by 7 would give me 210? So all you do is you take 30's radian equivalent, which is pi over 6, and since I take 30, and essentially what I'm doing is I'm multiplying 30 by 7, I take the radian equivalent and multiply it by 7. and that's the answer. Okay, so that'll be a lot quicker. Now, 360, number 10, that's pretty easy. We see that right there. That's 2 pi. Now, and I'm going to do things like number 7. I'm going to do a lot more of them. So if you're like, I get it, but Ms. Carter, chill out a second. I'll get there. All right, now number 4 is not a multiple of any of these guys. Listen, 99.9% of the time, you're going to get something that is a multiple of one of these guys. But if it's not, then you're going to do it the good old-fashioned way at the top of page 1, which is to just take that 160, put it over 1, and multiply it by pi over 180. Okay, so that's going to give me 160 pi over 180. I can cross those zeros out, and I see, well, 2 goes into 16 8 times, and 2 goes into 18 9 times, and that would be that. Again, you're not going to see that all that much. All right, make sure that you are writing everything down in your notes packet that I'm writing down on my screen right now. Okay, all right, so you're going to turn the page and we're going to go to page 2. All right, so I'm on page 2, and you notice off to the side, again, I wrote those special angles that we tend to see a lot of. The sooner you memorize them, the better off you are going to be. Trust me. Okay, you're going to be crying tears of pain if you do not memorize these. Remember, 3 goes with a 6, 3 goes with a 6, 45 has a 4 in it. Okay, now these go up in increments of a half. So this is 1/2, this is 1 whole. This is 3 halves, so like 1 1/2. This is 2 wholes, so a half, 1, 1 1/2, 2. Okay, so these are for your unit circle. So again, those go in increments of 1/2. All right, so now obviously we're doing 2 things, or we're doing one thing rather that's different. We are now going from radians to degrees, so we're going backwards. Okay, which isn't really that big of a deal, and I'll show you the trick on how to do this one as well. But obviously pi over 2, you can just look over there on my screen to the right, and we know that that's 90 degrees, so there we go. Okay, so here's where this trick comes in. This 5 pi over 6, and you know what? I'm going to just write that a little bit bigger so that it'll be easier for me to do what I need to do. Okay, so the trick with this is this. You're going to look at this, and I circle those numbers, okay? And then I particularly look at the denominator, and I'm like, oh, there's a 6 in the denominator. So I go over here, and I say, ooh, that means that this angle here is a multiple of 30. Follow? Okay, because this pi over 6 right here is like saying 30 degrees. Do you see that? Okay, so actually, you know what I'm going to do? Let me do this. So what I'm doing in green right there, that is equivalent to 30 degrees. Do you see that? And then all I'm going to do is take that 30 degrees and I'm going to multiply it by 5. Okay, and then that will give me my degree measure, which is 150 degrees. And there's your answer. Okay, all right, let's go down to 19. So 19 pi over 3, well, we can look over to the right and we know that that's 60 degrees. Nothing, insane there. Here we go. So 22. I'm going to just rewrite it up here because I have a little bit more space to write larger. 23 pi over 6. Okay, so let's kind of use that trick that I was showing you. And you're going to have time to practice this trick, so don't worry about it. So I'm going to look at this, and I'm then going to go over here to my list, and I'm going to say, oh, well, that matches up with 30 degrees. So we happen to have another 30 degree, like number 16. So I'm going to put 30 degrees here, and now all I have to do is multiply that by 23, and that will be my answer. Well, you should know that you can just really do 23 times 3, and then we'll just add the 0 at the end. Okay, so 23, let me get my color back here, times 23 rather, times 3 will be 69, and then we add the 0, so 690 degrees. You're going to find this little trick to be quicker eventually when you get the hang of it. And again, the fact that you will not be using a calculator for this, so you're going to have to figure this stuff out in your head. All right, so now let's turn to page 3, and we're going to just kind of skip around a little bit here, and let's look at number 1. So they want you to either convert, if it's in radians, convert it to degrees. If it's in degrees, convert it to radians. So if we look at number 1, there's a 6 in the bottom, so we know that that should be a 30. Okay, now but there's a negative in there. So don't worry so much about the negative. All that means is we're going to have negative 30 degrees as our answer, and that's why I wanted to go over this question. Remember, negative 30 degrees just basically means we always start on the positive x-axis, and if it's a negative, that means we're rotating clockwise 30 degrees, which lands us someplace, right around here in that 4th quadrant, okay? All right, so let's see. How about we look at something like, I'm trying to see. Let's go over to 8. I like number 8. Okay, and again, I'm just going to write it larger because I want to circle stuff. Okay, so now try to look and see and say, well, this is the special angle, and it has a 3 in the denominator, so that means it's a special angle of 60 degrees. And then I've got that 4 in front of it, so I'm going to do 4 times 60, which is going to give me 240 degrees. Okay, see how that works? All right, why don't you pause me and do number 6, and hint, it's like number 8. Okay, so you're going to want to circle that pi over 3. Okay, so pause me and work that out. All right, so you can look at my work right here, and you should see that you've got a reference angle of 60 degrees, and multiply that by 31, and you'll get 1,860 degrees. Okay? All right, so let's go down, and let's look at some of the ones that are in degrees, and we want to convert them to radians. How about we look at something like number 12, negative 660 degrees. Okay. Anything that's in degrees, if we want to convert it to radians, and that's kind of a weird one, we're just going to divide by 180, and then we'll stick a pi next to our answer. So I'm going to cross out that 0 and that 0, and then I'm just going to divide 66 and 18 by a common factor. And let's see, 6 goes into both of those. So that would be, I'm going to just write it, where am I going to write it? Right up here, because I'm kind of out of room here. Now there is a negative, so I'm going to keep that negative there, and I'm dividing by 6, so that would be negative 11 on the top and a 3 on the bottom. And then what you do is, when you're converting something to radians, you want to have a pi. Okay, now the pi has to go in the numerator, or some people will write it, let me just kind of throw it down here. You can write it like this, negative 11 over 3, and stick the pi kind of in the middle there. Do not ever, though, write that pi in the denominator with the 3. That is considered incorrect, okay? Alrighty, let's turn to page 4. So here we are back at page 4 again, and we're back to the special angles in the unit circle. So again, just as a reminder, these are the angles that we're going to focus a ton on in this course, as well as these, what we call quadrantal angles, 0, 90, 180, 270, and back to 360 again. Okay? And now what I would like to do is I would like to talk about the numbers that surround this. So let's talk about the unit circle quickly, because I know that you guys have done this. So right here, if we were on an XY axis, and here I am at the origin, and I just go out 1 unit to the right, the coordinates of this point right here are 1, 0. And so that's where this comes from. And if I go up 1 unit, the coordinates of this point right here would be 0, 1. Same thing here, negative 1, 0. Same thing here, 0, negative 1. And I hope that you remember, but if you don't, you can write it down right now in your notes. Remember that your x value will always correspond with cosine, and your y value will always correspond with sine. And then we have y over x, and that corresponds with tangent. Okay, now if that rings a bell but you're kind of not quite so sure, hold on, it will make sense in a minute. Okay, all right, so let's go down and let's just try an example so you kind of understand what I'm talking about here. So let's look at number whoops. I thought I had my pointer on and I did not. Let's look at number 3, tangent of pi over 2. Okay, well, pi over 2, we should know, is 90 degrees, which is right up here. Okay, now if I want tangent, I do the y value over the x value. So look up here, this is 90 degrees. Y value is 1. So let me write that down. 1, and the x value is 0. So there's your tangent of 90 degrees, or pi over 2. Now 1 over 0, by the way, is not 0. When you have 0 in the denominator, that is considered undefined. Okay, so you can write it as 1 over 0, or you can write it as undefined. Okay? All right, I'm going to skip around a little bit. Let's look at number 5. So 5 says the tangent of pi. Okay, so now remember, this is 0, this is 90, which is pi over 2. Remember, things go up in increments of a half. So this is 1 pi over 2. So this is like 2 pi over 2, which is really pi. Okay, so this is pi. 180 degrees is pi. So the tangent of 180 degrees is what this is asking for, which is right here. Okay, and again, tangent is the y value over the x value. So the y value, which is 0, over the x value, which is -1. Okay, so we've got 0 over -1. Now look at the difference between number 3's fraction and number 5's fraction. I mean, aside from the fact that we've got a negative there. 0 in the denominator means undefined, but look at this. 0 is in the numerator, so just remember, 0 in the numerator means 0. Okay, so look at the difference between those two. All right, let's skip to number 6. So now we've got 3 pi over 2. Okay, now remember, 3 pi over 2 is 270. We've got 1 pi over 2, 2 pi over 2, 3 pi over 2, right down here, 270. And we want the sine of 270. Okay, sine is the y value. So here's 270. Look at the y value. It's right there, -1. Okay, so that's kind of an easier one than tangent. So that's -1. All right. Okay, let's go to number 7. 7 says the cosine of pi over 2. All right, pi over 2 is 90 degrees. Cosine is the x value. And then, so if you look at that, that would be 0. And let's go to number 9. Okay, number 9. Now this one's a little tricky because we've got a negative here. This is 270 degrees, but in the negative direction. So you ready? Here we go. We always start here. Now going in the positive direction is this way, but we are going to go in the negative direction, and we're going in the negative direction 270 degrees. So 90, 180, 270, right there. So we're going to do tangent, which is y over x. Okay, so that is going to be 1 over 0, and remember, 0 in the denominator means undefined. Okay? All right, so then let's look at what I kind of left out. So number 1, sine of pi over 6. Well, we know pi over 6 is 30 degrees. So 30 degrees, we want the sine, and it's right there, 1/2. Okay, so this is 1/2. All right, why don't you take a quick second and you can fill in 2, 4, and 8. All right, so take a minute, look those over, make sure you got the same answers. All right, now something I skipped over that I skipped over on purpose, but now it's time to address it, is How did we get that sine, cosine, tangent of 30, 45, 60, that chart that's on the top left of page 4? And you did learn this last year, but I just want to make sure everybody remembers. So we go in, remember good old-fashioned SOHCAHTOA? So we go in SOHCAHTOA order. So sine, cosine, tangent. And by the way, that's after we make this little 3x3 tic-tac-toe board. Okay, so it's sine, cosine, tangent down the left-hand side. And then across the top, we go in numerical order from the lowest number of 30 degrees up to the largest of 60. Now, we're not doing the quadrantal angles with the unit circle. We're just talking about the things that are acute angles that are not in the unit circle. So 30, then 45, then 60. Okay, so I know that I taught this to you, and I know your Algebra 2 teacher taught this to you, but I'm going to go through it real quick. So you ready? 1, 2, 3. Then we go 3, 2, 1. So 1, 2, 3, then 3, 2, 1. Every single one of those numbers will become a numerator, and every single denominator is going to be a 2. Okay, and then if you remember, every numerator is going to get a radical. Now, the only reason why I'm skipping the 1 is because the square root of 1 is 1. You can put it there. It's just not necessary. Okay, so just real quick, we had a 1, 2, 3, 3, 2, 1. All the denominators are 2. All the numerators get radicals. Okay, but the 1, you can put it there, doesn't need it, because the square root of 1 is 1. All right, now, the last row here, this is the best I got for you. The middle will always be a big fat 1. Okay, now the left and the right bottom boxes there, they are both going to have a radical 3. So here's the way I memorize it. If you have a better way, go for it. This radical 3, watch, it corresponds with 30 degrees. So 30 degrees gets the extra 3. Okay, so again, 3, 3. This doesn't have a 3, so this doesn't get a 3. So that's where that comes from. So you're going to have to memorize that. So this is just kind of like a good cheater method and a good way of memorizing. Okay, so lastly, just some clarification and application of page 4. Okay, so I'm on page 5, and I'm not going to do all these questions, but let's look at number 10. So the sine of pi over 6, and again, you could look that up, but you want to start to memorize that. Okay, and that is going to be 1/2 plus the tangent of pi over 4. And again, that's something that you want to memorize. So the tangent of pi over 4, which is really 45 degrees, okay, is 1. And then all we do is 1/2 plus 1 is 1.5, or you could say 3/2. Okay, whichever you prefer, it doesn't matter. Let's go over to number 12. So the sine of 3 pi over 2, remember 3 pi over 2 is 270 degrees. You're looking for its y value. Okay, if you need to pause me to look this stuff up, please go ahead and do it. It's on page 4. I have -1 minus, and then the cosine of pi over 3, that's 1/2. And then when I add those, that's -1.5, which would be -3/2. Okay. All right, let's look at number 14. Cosine of pi over 4 is radical 2 over 2 plus the sine of pi over 4, which is also radical 2 over 2. Now, I did this one on purpose because I know that one's going to be a little weird. You need to understand that technically there's a 1 here and there's a 1 here. So when you are adding, okay, now remember with fractions, when you're adding, we keep the denominator and we just add the numerators. Well, 1 radical 2 plus another 1 radical 2 would be 2 radical 2. Okay, and then we can look at this 2 here and this 2 here, and they are like terms. So like with fractions, we can cross those out. So our final answer for that is just going to be radical 2, and that's why I wanted to go over that one. Okay. All right, let's just try one more. Let's look at number 16. Okay, so 16, what they want you to do is, look, this is x, and this is what they're replacing x with. So they're asking you to put in a pi over 2 everywhere you see an x. So here we go. So cosine of 3, and now I see an x, pi over 2. Plus sine, now I see an x, so pi over 2. And now we just look that up, or we memorize it. Remember, 3 pi over 2 is 270 degrees, and cosine is the x value, right? So that's going to be 0, plus, and pi over 2 is 90. So we go up to 90, and sine is the y value, which is 1/2. And who just caught Miss Carter's mistake? That's 1. So the answer is 1.